Okay, so the proof that we are going to try to do right now is proving that square root of 2 is irrational. And the proof that we are going to do is a proof by contradiction. Which means that we assume first the contrary of the statement that we are trying to prove. So that means that we assume that square root of 2 is rational, and we try to reach a contradiction from there. So the way we would do that is, and we will try to reach a contradiction. So this means that square root of 2 is equal to some fraction b divided by a, such that this is the most reduced form, so that b and a are relatively prime. And this means that the GCD of a and b is 1. So from this, we can say that, from this formula here, we can say that 2 is equal to b squared divided by a squared. And this tells us that b squared is equal to 2a squared, so that we can, since it's equal to a number multiplied by 2, that means that b squared is even. And since b squared is even, we can deduce that b is even, because if it wasn't, then if b squared was even, there is no way for b to not be even. So that means b is even. And from there we can, so since b is even, that means we can write it in the form of 2 multiplied by some number. That's the definition of a number being even. So from this we can substitute this in this formula, so that we can get a formula for a squared. So this means that b squared is equal to 4 multiplied by c squared. And since b squared is 2a squared, that means that 2a squared is equal to 4c squared. And from this we can say that a squared is equal to 2c squared. And from this formula again, we can deduce that a squared is even. And since a squared is even, that means that a is even too. And since a is even here, that means that we have two numbers, a and b, where a is even and b is even. Plus we have that the GCD of a and b is equal to 1, that a and b are relatively prime. And this is impossible, because if both are even, that means that they are both divided by 2, which is a contradiction. Which means that our assumption is wrong. And by this we end our proof, and we can say that square root of 2 is irrational.